Okay, we'll be needing your calculator a little bit later. We are going to be doing system of equations that are second degree equations. And again, as with the other notes, I'm probably not going to do every single example. Some of them are pretty straightforward. But of these first, let's see how many we got here. Yeah, these first four, I'll probably definitely do two, maybe three. Okay, so system of equations that are second degree ones. Again, there's different ways to do each one of these, but all right, so for this first one here, it's kind of a glare here a little bit. Well, hopefully you can see this. Hold on one second. That didn't help. Okay, so the first thing I'm going to do is take this second equation here and solve for y and get 12 over x. And then plug 12 over x into the first equation and then where there's a y. So I'm going to get x squared plus 12 over x, the quantity squared, is equal to 25. And now just simplify it. So that's x squared plus 144 over x squared is equal to 25. I'm going to multiply through by x squared. So that's going to give me an x to the fourth plus 144 equals 25 x squared. And then x to the fourth minus 25x squared plus 144 is equal to 0. We're going to factor x squared, 16 and 9, I believe that is, minus 9, and then minus 16. So we get x is plus 4, x minus 4, x plus 3, x minus 3. So I got all these answers here. X equals plus or minus 4, plus or minus 3. And now I have to figure out what all the y values are. Okay, so I'm going to take these solutions here and plug them into right here. That's the easiest place to do it. So I'm going to get y equals 12 over 4. Then I have to do 12 over negative 4. Then I'm just going to do them all at once. 12 over 3 and 12 over negative 3. All right, so your solutions are going to be, if I plug in 4, 12 divided by 4 is 3, so I get 4 comma 3. This one's going to be negative 4 comma negative 3, then 3 comma 4, and then negative 3 comma positive 4. Okay, and there's all your solutions for this. I am going to take the time right now to show you how to enter this in your calculator and get the solution set for this. All right, I'm not going to do it for all of them. But to use your calculator, they basically both have to be y equals. So that one we already have is y equals. This one we have to get in terms of y equals. So just solve for y. So y squared equals 25 minus x squared. Take the square root of both sides. You're going to get y equals plus or minus the square root of 25 minus x squared. Okay, so you grab your calculator here. Hopefully you can see the calculator. We go to y equals, so the first one's going to be our 12 divided by x. Second one, now I have a plus and minus version, so I'm going to do second square root 25 minus x quantity squared. And then down here, I'm just going to do negative alpha trace y1. I want the negative of what's in y2. All right, I'm going to do zoom 6, graph these, see what these look like. So there's that rotated hyperbola. Here's your circle. What the heck is that? Oh, I'm sorry. Okay. Wait a minute, something's not right here. Oh, the opposite of what's in y2. Alpha trace y2. I did what's in y1. There's a mistake you don't want to make. Okay. Hyperbola, hyperbola, top of the circle, bottom of the circle. And then the intersection points. Now it's very difficult to see, but there's 2 intersection points over here and there's 2 over here. So this is a good place to use zoom box. Go over to here, check out what's going on. Zoom in here. And we'll zoom in, and you'll be able to see that it intersects. It's still really close, but you can see it. Now I'm going to get just one of the intersection points for you. So second trace, intersect, and I'm going to go to there, hit enter. The second curve, make sure you're on the right part. Up here it tells you where you are. You're on the circle part and the positive part, so I'm at the top of it. So just make sure they're right there. And then you get one of the points is 3, 4. And then you can go around and get all the rest of them. Okay? All right. All right. I don't know. Let me just see. I think the second one, the second one I'll leave for you to do on your own. All right. So the third one here, I'm just going to rearrange the terms here a little bit. 5x squared plus y squared equals 30. And this I'm going to get negative 9x squared plus y squared equals positive 16. And I'm just going to switch the signs to make these opposites. So I'll make that negative. I'll make this negative, and I'll make that negative. So I get negative 14x squared. Just cancel out. It's going to be what? Negative 14. How convenient. X squared equals 1. Take the square root of both sides. X equals plus or minus 1. All right, and then you're going to plug them back in. I guess there's no good place to plug these back in. So I'll plug them back in the top here. So I'm going to do 5 times 1 squared plus y squared equals 30. Now when you plug in plus or minus 1 here, they're both going to give you a positive 1, but I'm just going to go through and do it. That's going to be 5 plus y squared equals 30. Y squared equals 25. Take the square root of both sides. Y equals plus or minus 5. So, and if I put in negative 1, I'm going to get the same thing. So it's basically, here's a shortcut way to write it. Plus or minus 1 goes with plus or minus 5. But just make sure you know the ordered pairs that go together. So 1 goes with 5, 1 goes with negative 5, and so forth. And then negative 1 with both of those. Okay? Yeah, I guess I'll do this one. The numbers end up being a little bit messier than these other ones. But so for here, I'm just going to multiply through to make the y squareds the same. So I'll multiply top by 4. So I'm going to get a 20x squared. That's going to give me minus 16y squared. And 4 times 20 is 80. So I get 24x squared. Those cancel out, equals 144. X squared equals 144 divided by 24. I believe that's 6. Yeah, 6. So now I take the square root of both sides and I get x equals plus or minus the square root of 6. All right, then you got to plug in, doesn't matter where. So 5 times the square root of 6 minus 4y squared is equal to 20. So that's going to give me a, squared. It's going to give me a 30 minus 4y squared equals 20. Negative 4y squared equals negative 10. Y squared equals 5 halves, square root of both sides. Y equals plus or minus the square root of 5 over the square root of 2, which simplifies to the square root of 10 over 2 plus or minus. All right, so you're going to write them as ordered pairs like we did in these other ones. But again, to keep this video fairly short, I'm not going to go through and write them all as ordered pairs. Okay? And again, they could get a little bit messier in that, but that's kind of the general idea. All right, next thing. Next thing we do is just graphing of these. And these are inequalities. So just watch for greater than, meaning these would be always solid lines. These are going to be dotted lines and solid and solid. When you get to example number 3, there should be a squared there. It's a typo. I think it's missing. Okay? All right, so first thing we're going to do is graph each one of these. So we know that this here is going to be a hyperbola because one's positive and one's negative. So let me rewrite this, setting it equal to 1. So x squared over 16 minus, when I divide by 16, it's going to be y squared over 1 greater than, I just said 1 and I wrote 16. 1, and then greater than or equal to 1. And then this is just going to be a circle, so we can leave it as is. So it's going to be the intersection of a hyperbola and a circle. And we're just doing the inequality greater than or equal to that. All right, so here, let me do the circle first. So center's at 0, 0. And make sure you can see that. I go out 7, up 7, left 7, down 7. All right, it's going to be a circle. Do the best you can here. It's a solid line. Again, just be careful of dotted versus solid. All right, and then hyperbola here. So this center, actually, hold on, let's take care of the inequality here. So they want everything greater than or equal to. I just always test the point and take 0, 0. If I plug in 0, 0 in for this, I'm going to get 0 plus 0. It's not greater than or equal to 49. So I know the solution for shading of this is on the outside. I'll get to that in a minute. All right, now this one, the parabola. So, or excuse me, hyperbola. Center's at 0, 0. Along the x-axis, go out 4. Along the y-axis, you go up 1. You're going to draw a little rectangle here. Okay. Draw in your asymptotes that are the diagonals of the rectangle. I've got to turn the paper for a second. Okay. The squared term is x, so it's going to open in here. And again, that hyperbola is a solid line because it's greater than or equal to. And I'm going to pick a point again, but it's greater than. But if you're not sure, I'm just going to pick this point here, 0, 0. So if I plug that in for there, I get 0 over 16. 0 minus that's going to be a 0. Is that greater than or equal to 1? No, it's not. So it's going to be, it's outside the circle, but inside the hyperbola. So it's going to be this stuff here, which is your solution. Okay? Okay. Okay, and now we'll do this last one here. I'm going to skip that middle one. That's on your own. Just make sure for this middle one you make them dotted. All right, but make sure you do it because I'm going to check that you wrote it down. Don't just copy it from somebody. All right, so again, remember there's a typo there, so put a squared there. So I'm first going to rewrite this. Since I know it's a parabola and there's the squared term, I want to get the non-squared term by itself. So I'm going to go x less than or equal to y minus 1, the quantity squared. And then I'm going to, I have two squared terms, so this is either an ellipse or a hyperbola. So I'm going to move the x over. So it's going to be negative x squared plus 4y squared greater than or equal to negative 16. Now I'm going to divide by negative 16 because I want to get it equal to 1. So when I divide by negative 16, this sign's going to switch. That sign's going to switch. Make sure it's over 4 because you're dividing by 16. Don't forget to flip to inequality because you're dividing by a negative number. And then that's going to be equal to 1. All right, so for this, again, I got a hyperbola. So center's at 0, 0 again. I go out 4 on the x-axis. Hopefully you can see that. Yep. And then up 2. Make my dotted line rectangle. Now I'm going up 2 over 4, so I go up 2 over 4, up 2 over, that'll take me off the graph, and then down 2 over 1, 2, wait a minute, down 2 over 4, down 2 over 1, 2, 3, 4. All right, so there's that diagonal. And then the same thing this way, up 2 over 4, up 1, 2 over 1, 2, 3, 4. And then down 2 over 4, down 1, 2 over 1, 2, 3, 4. All right, got to turn paper for this one. Okay, so that's squared term is x, so it's positive, so it's in here. Now again, I'm going to try the point 0, 0. So if I plug the point 0, 0 in for that, that's going to give me 0 minus 0 is less than or equal to 1. That's true. So it's going to be shaded for right now in between these, I guess I'll say. All right, now this graph. That is going to be a parabola that opens up sideways. So here, I'm going to rewrite it down here. X less than or equal to y minus 1, the quantity squared. So the vertex for this is at 0, because there's no plus an x value out there. So 0, comma 1. So that's right, whoops, right there. And it's going to open to the right because it's positive. And then I'm going to go up 1, over to the right 1, up 1, 2, over to the right 1, 2, 3, 4, and up 3, 1, 2, 3, over 9, 1, 2, 3. Well, does it take me to the end? It's going to take me right there. So I'm in like this. And then same thing down here, over 1. And this one would be like right there. And this one would be right there. All right, so it's kind of difficult to see, but it's kind of overlapping. Again, I'm going to try the point 0, comma 0. So if I plug in 0 for x, I plug in 0 for y, I'm going to get negative 1 squared, which is 1. 0 is less than, so not less than or equal to, but it's not a good point, so I can't, oh, 0, comma 1's right there. I'm sorry, it's right there. I thought it was there. Okay, so it's in between the hyperbola branches and outside of the sideways turned parabola, so it's all this that's in here. Just make sure, be careful right here. It's like outside that and outside that. Kind of give this a nice shading here. It's difficult to say. All right, but there's the graph of it. What I would like to do is I actually graphed it on Desmos, so I'll show you what it looks like. You can just be patient with me for 1 second.